Okay, what we are going to do is we are actually going to take a look a little bit at some of the organizational information on the periodic table. So let's first take a look at how we read the squares on that periodic table. Okay, so we have here a sample square. Now this sample square actually looks a little bit different than the one that you have, but this also helps you read pretty much any square on the periodic table. The first thing you notice is in this square we have a number that is a decimal, and this is actually the one that is missing from your periodic table. This is representative of the mass. The bottom number here is the whole number, and it is the atomic number. Now your periodic table actually has that whole number, so you just have to be able to, read basically the square, and there's always a key on that periodic table for you.
Tell us a great deal about each individual element and the family to which it belongs. Each element has its own box with specific information supplied. In the center is the symbol for the element. The symbol is a 1 or 2 letter abbreviation. Scientists want a quick way to represent elements, so a symbol has been given to each. Under the symbol is the name of the element. At the top of the box is the atomic number, which tells the number of protons in each atom. At the bottom is another number. That is the atomic mass of the element. Notice that the atomic masses are not whole numbers. Recall that this is because they are averages.
And we discussed that those were averages when we first took a look at the periodic table. Alright, so now let's take a look at the actual organization of the table. The first way that we can organize the table is in periods, and periods run left to right on the periodic table. So they are defined as a horizontal row of elements. Sometimes these are also called a series. Now, periods are tied in to energy levels. And if we think back to the Bohr model, when we drew the Bohr model, we can actually kind of see this. When we drew the Bohr model, we had a nucleus in the center, and then we had rings of electrons around the outside. Sorry, I'm not very good drawing with the mouse. In any case, so the energy levels correspond to those rings. So the number of the period is actually equal to the number of rings of electrons that are around the atom. So for instance, if we take a look at how many energy levels are in each element in period 5, since the period number is 5, the number of energy levels would be 5. Now, on the periodic table, we actually have 7 total energy levels. And those go from top to bottom, and you should see numbers starting next to hydrogen, and then again next to lithium, sodium, potassium, rubidium, cesium, and francium. The 2 rows at the bottom do not actually have period numbers. Okay. Oops. All right, now groups. Groups run from top to bottom on our periodic table. So they are defined as a vertical column of elements on the periodic table, and their key is that they share similar chemical properties. Sometimes we will see these referred to as a family. Now, valence electrons, which is a new concept that we have not talked about, are related to the group number. Valence electrons are the same for each element within a group. So what exactly are valence electrons? Well, if I go back to Bohr, with my nucleus and my rings, and my rings have electrons on them, these 2 electrons are the ones in the outermost ring, and those are our valence electrons. That's what that is. So valence electrons are the ones that are in the outermost ring of an electron or of an atom. They are the ones that are furthest from the nucleus. So what we can tell based on the group number is the number of valence electrons. So in general, the number of the group is equal to the number of valence electrons. Now, if I have a group number that is greater than 10, the number of valence electrons is the ones place. So, if I look here, how many valence electrons are in group 2 elements? Well, group 2 is less than 10, so the group number here is equal to the number of valence electrons. So all group 2 elements will have 2 valence electrons. How many valence electrons are in group 16 elements? Well, 16 is greater than 10, so I look here at the ones place right underneath, or look at that 6, and that tells me it has 6 valence electrons. Now, some of you may be wondering, well, what happens if we have 10? Is it 0? And the answer is no. Actually, for groups 3 through 12, you will not be determining the number of valence electrons. And that is simply because their electron configurations are such that unless you're taking a more advanced chemistry course, I'm not going to expect you to know what those valence electrons are. So we can divide our periodic table into rows, known as periods, or groups, our columns. We can also divide them up into big categories, like our metals, which we talked about last unit. 85% of the elements on the periodic table are known as metals. Properties of metals include that they are shiny, opaque, which means you can't see through them, good conductors of heat and electricity, they are malleable, in other words bendable, and ductile, they are stretchable. Metals are solids at room temperature, with the main exception being mercury, which is a liquid. Metals are located to the left-hand side of the periodic table, specifically to the left-hand side of the staircase. Our second large group are the nonmetals. These are poor conductors, and they can be transparent so you can see through them. They are brittle and they shatter easily. Nonmetals exist in all 3 phases. We have a bunch of gases like hydrogen, helium, oxygen, nitrogen, fluorine, neon. We have a liquid in bromine, and several solids, sulfur, iodine, and astatine. Nonmetals are located on the right-hand side of the periodic table. So they're located to the right of the staircase. The metalloids are 6 elements that are located right along the staircase between the metals and the nonmetals. And this includes boron, silicon, germanium, arsenic, antimony, and tellurium. Their properties are a mixture of both metallic and nonmetallic properties. So these are very element specific. In other words, the elements, the metalloids, you can't say, oh, well, they're all good conductors, but they're all brittle. One could be brittle, one could be malleable. It just depends. So you will not be asked to predict the properties other than to know that this general idea that they are a mixture of these properties. And like I said before, these are located right along the boundary, right along the staircase on the periodic table. Is that not playing? Okay, apparently that is not playing. So that is actually a clip about some of the different atomic groups, and I'm not sure why it is not playing. Okay, but we'll move on. So what the video was going to preview is actually the groups that we are going to be talking about here on the periodic table. So the first group that we have are the alkali metals. These include all of the group 1 elements except for hydrogen. And these are the most reactive metals on the table. All of the group 1 elements have 1 valence electron, and the name alkali comes from the Latin that stands for ashes. Ashes and water form a slippery substance that actually cuts grease, so these elements are actually useful in making soaps. And here are our alkali metals. The next group name are the alkaline earth metals. These are the group 2 elements, and they are very active, but they're not as active as our group 1 elements. They have 2 valence electrons. These form alkaline or basic type solutions, but they are fire resistant, and they were called earth substances by the medieval alchemists, which is partially where we got their name. And this includes these elements. The transition metals are located in the very center of the periodic table, and they are groups 3 through 12. These are typically less reactive metals than the alkali and alkaline earth metals, and this is why we can use them for our everyday purposes. For instance, copper we use in coins. You don't want the coins actually reacting with the skin while you hold it. That would be bad. Transition metals are actually known for producing colored solutions. In fact, we have several colors that are actually named or associated with colors. For instance, cobalt blue and even copper. When we say copper, we actually not only think of the metal, but we think of the color. This is actually a series of different solutions that were formed using vanadium. Another group is the halogens. These are group 17. These are called salt forming because when they form a compound, we call them salts. These, of all the elements on the table, these have the most nonmetallic properties. And they have 7 valence electrons. And these are some of their members. The last specialized group that we want to look at are the noble gases. These are our group 18 elements. They are extremely unreactive, so sometimes we call them inert. In other words, they don't actually like to form compounds. All of them, except for helium, have 8 valence electrons, being in group 18. Helium is the only exception, and it only has 2. It's the only exception to the valence electron rule on the entire periodic table. They're called noble gases because they act almost like the medieval nobility that didn't mix with the commoners. So because they don't make compounds with the other elements on the table, we tend to think that they keep themselves separate. Now, everybody always asks me about the last 2 rows at the bottom. Why are they put there? So hopefully, let me see something. Yes. Because I do want this to play. Alright, let me go through this, sorry. Alright, let's play this.
About the 2 rows of elements that appear out of order and at the bottom of the periodic table. Well, they are shown that way to save space. This is what the periodic table would look like with the 2 rows in their proper positions.
So, the 2 rows at the bottoms are put there simply because to save space. If you look at the size of the periodic table on a piece of paper, it wouldn't fit if we had it this way. The squares would be very, very small. The rows at the bottom have no group number, and each row has such similar chemical properties, they actually form their own group. The top row is called the lanthanide series, and this is elements 57 through 71. These were difficult to purify because they were so similar, and we use several of them in making laptop screens. The bottom row is referred to as the actinide series, elements 89 through 103. The most famous of these are uranium and plutonium because we use those in nuclear power plants. All of the elements after uranium are actually man-made. So, this is kind of what that periodic table looks like. So what we're going to do is you are actually going to use your colored pencils and the markers, and we're going to be coloring our periodic table. So let me get mine set up here. Alright, so first we're going to start off with colored pencil, and we are going to color this first column here. Okay, and those are our alkali metals. So we're also going to make a little key here. Oops. All right. Group 2 we will do in a different colored color pencil. And it is our alkaline earth metals. This group here in the middle shade those in with another colored pencil. These are our transition metals. Another colored pencil. Over to here. These are the halogens. And lastly, you have to include helium, and then the rest of group 18. And these are the noble gases. Okay. Now, we're going to use that last colored pencil, and we're going to color in some specific elements, not an entire row or group. We're going to color in boron, silicon, germanium, arsenic, antimony, and tellurium. These guys are our metalloids. Now, we're going to switch over, so I'm going to actually erase my shading from my colored pencils, and you're going to switch to one of your marker colors. With that marker, you're going to make the following outline on your table. Now, on your table, you guys actually have more down here, so I'm going to take it out like it's the whole row, even though mine doesn't have any there. You're also going to include these guys down here at the bottom, both the lanthanide and actinide series. And again, you are just outlining them with marker. This outline represents our metals. I'm going to switch to a different color, and now we're going to outline helium, and we will also outline hydrogen. Sorry, my marker seems to be a little bit slow. And then starting with carbon, and then up and over. These guys are our nonmetals. Okay, so now you have a periodic table that talks about all the different groupings that we discussed in class, and the names. Now, you will not have something like this on the test, but this is something really good that you can study from. In our last section of notes, we are going to have to talk about periodic trends, and we will also be doing an activity that has us take a closer look at these periodic trends.